The next talk will be held by Francesco Sacchi. Francesco is a project manager at Develer, and I'd like to say again that Develer is the company that organized the GoLab, so I hope you will enjoy this talk too. And so let's start, and Francesco, you can start.
Thank you. Okay, welcome. Good afternoon. First of all, who am I? I'm Francesco Sacchi. I work for Develer, as Fabio has previously said. I'm a project manager for embedded projects. And this is the summary of today. I will talk about Go and IoT. This is a beginner talk, so it's not meant to be too difficult. There will be an introduction to our IoT platform and architecture. We have called it Nubila. We will see some features of our client software for this platform. I will show you some source code, architectural choices, and there will also be a live demo of the client and the platform. So let's start. What is Nubila? Nubila, we call it an Internet of Things cloud connector. It's meant to be used for embedded devices, so they can communicate with each other, interact over the internet, store data to the cloud, on the cloud. And we will also are planning to supply connectivity for this device, mobile connectivity. Nubila actually is a commercial product made by Develer. It's composed of three things. There is the platform, the cloud platform. There is an OEM module, a system of module, a small embedded board, this, with a GPRS or UMTS modem on board, which can communicate over the internet to the cloud. And we also plan to supply mobile connectivity, so we will plan to ship the module with a SIM inside. This is the main architecture of our cloud platform. We have the main cloud system there with a database, a web dashboard to inspect the data collected. There is an MQTT broker, and then there is the module here. So all these things speaks MQTT. And there is also a Nubila client written in Go, which run on Linux or OS X systems. Okay, these are some details of the cloud platform. You can see the cloud platform currently work on Heroku. We have MongoDB as a database and MQTT for talking with the broker. And down here, some details as well. Currently, the module speaks GPRS. And over GPRS, we have an MQTT protocol, and even there. The Nubila client, as I said previously, runs on Linux and OS X, and can be interfaced with a user app to send and receive data from the cloud. Why Go? Why we have decided to use Go for our client solution? Because it's multi-platform, so the client can be compiled for Windows, Mac, or Linux very easily. Binaries are static, so there are no dependencies. We can ship it, and that's all. And Go development is very easy and very fast. And also, we have good performance, even if performances are not critical in this application. Let's talk about the communication layer. As I previously said, we use MQTT as the messaging protocol for all the things connected. And we decided to use PAHO as a client-side implementation of the MQTT protocol. PAHO is a library developed by Eclipse, and it also works with Go. So let's start. Things communication. Each device connected is called thing, and each thing is identified by a unique device key, so we can identify each thing connected. And as I said, all MQTT messages related to a thing pass through a specific subtopic things, device key, and so on. So each key have, each thing have its own topic on the MQTT protocol channel. Currently, we have two main concepts in our cloud platform, and are implemented in the client as features. We can send events, and we can read and write properties. What are events? What events are? Events are gated from the field. They are only from the field to the cloud platform. So you can only send events from in one direction. They are in the form of a key-value pair. Can be collected, stored, organized on the platform. There is a specific topic used for sending events. And for an example, if you want to send a temperature read from a sensor, this is an event. If you want to read humidity, this is an event. Each time you send the same key, they are collected in a database, so you can later retrieve it. Properties, instead, are read-write. So you can read properties from the field, but you can also write properties to the field, to the embedded device connected. There is no history, so you have only the current value of the property. There are specific channels, specific topics to send and receive properties from the device connected. And they are typically used for configuring the device or configuring the client in general. So they are meant to be used as a configuration tool for the device. OK, this is a summary. As we can see, there is the MQTT broker. And currently, we use Mosquito. I don't know if you know it. It's an open source implementation of an MQTT broker. Then there are these topics used by the client. The event topic is used for sending events to the cloud. The properties topic used for sending properties from the field to the cloud. And action is used to change a property on the device from the cloud. Then a user app can interface to the client to access the cloud. So how these features are implemented in the client? We decided to have files as a main interface for our client because they are easy to understand. They are easy it's easy for other programs to read, write files, and they can also be used in a very, very easy manner with command line tools for debugging purposes. So let's see how we can send events. Actually, previously I said that we use files. Actually, we use a FIFO, a named pipe, to send events. There is a FIFO on the file system called events, and the Nubila client is blocking reading this FIFO. So a user can write to the FIFO, and the client can read from the FIFO. And we can send an event simply by writing to the FIFO a key-value pair. OK, I don't know if you can read it. But this is the code who handle the event loop. First of all, up here, the FIFO is created. And then we are blocked here reading from the FIFO. If someone write to the FIFO, this open go on. And so we can read from the FIFO. And then we split what we have read here. Here. We split what we have read from the FIFO, and then we store the event send here. This calls store the event on the cloud. So it's quite easy. OK. I also have a demo of this. OK. This is the dashboard I said before. This is These are all the devices connected, registered, sorry, to my account. This is my MacBook, which is offline right now. So, allora. Okay. I started the client on my MacBook, and the MacBook is online now. So, here we have the FIFO, here, events. Can you see it? Okay. And if I write here something, okay, as you can see, random goes 1, and so on. Very simple. Okay. Okay, let's talk about properties now. We decided to use a directory sub-tree for containing the properties. This directory has other directories inside. We call it sections. And inside each subdirectory, there is one or more files which contains the property. There is only one level of subdirectory. This is an example of what I have right now on my Mac. Directory name is the name of a section. So, for instance, here we have system, which contains the file test point hint. And here in the dashboard, I have system as well, and the test property is here. We can use, if we want, a file extension, test.int, for instance, to specify the type of the property. Type, in this case, it's an integer. Okay, how can we read properties from the device? We use fsnotify, which is a file system notification system, multi-platform. It's a library which is available there if you want to check. And we have two watchers, one for directories, which monitors section creations, and we also have another watcher who monitors for files. Okay, this is the piece of code who handles the properties. I cannot reach there, however. The first part of the code, the case up there, is linked to the watcher of the directory. So we can monitor if a directory or a section is created or removed, and add it to the notifier for later notification. And down here, we monitor for file modifications. So if a file is created, removed, renamed, or written, we subsequently notify the property system inside the Go program to handle this event. At the end, properties are sent out from the device to the cloud. In memory, properties are stored as maps because it's an efficient way to store this kind of structure in memory. Sorry. This is the code used. This is a piece of code which reads the directory and sends it to the cloud. First of all, the directory is opened. Then, sorry. This directory is opened. Then we read the content of the directory, and each structure is created one by one. If it's a directory, then it's a section, and inside the section, we look for files, we read files, and then we create the property at the end. We also have a special field for type of the property and the value. Okay, let's have a demo now. Here are the properties. So we are inside the property sub-tree here, so you can see there are the same directories here and there. System, test, and test 1. So if I go inside here, system, and I can read the content of this file, is 44. The value changes on the system here. I can also change the value from the cloud. And then the value is changed as well on the file system. Okay. There is, as I previously said, there is another topic who sends modification back to the device from the cloud. Because the client saves the properties to the disk, it's not easy to react to this event. You should, or you can set a notifier as well to the file. Or you can also use another mechanism which we have implemented for immediate action. We have another set of FIFOs, another set of named pipes called action. So you can read from that FIFOs to have notifications from property change from the cloud. Let me show you. So here, there are this set of FIFOs from action 0 to action 7. If I cut from action 0, for instance, I can receive messages here when I change a property from the cloud. So you can read this file, this named pipe, to have instant notification of property changes from the internet. Okay. And this is the code who handles this, because there is this is a callback registered to be called when a message arrives to the action channel. First, the message is unmarshaled because we use JSON as a messaging protocol inside MQTT packets. Then the message is parsed, and in the end, an action is shipped to the FIFO. Okay, here it should be the demo. Okay, so summary. This is the client. Here is your user app. You can send event by writing to the event FIFO. You can read properties from files directly, and you can receive properties as actions from the previous FIFO I showed you. Okay. Thank you.
Someone want to ask something to Francesco? No one? Okay, so thank you, Francesco.
Thank you.